Hello class, in this video I'll be showing you how to find the relative extrema of a function by applying the first derivative test. Let's begin. So what are the relative extrema of a function? Assume that c is a critical number of a function f of x in the open interval ab. Then c is the location of a relative maximum if f of c is greater than f of x for all x in the interval a, b. C is the location of a relative minimum if f of c is less than f of x for all x in the interval a, b. Now I'm going to describe the relative maximum and the relative minimum of a function by showing you a graph. In this example, c is the location of a relative maximum. And that is because in the open interval from a to b, f of c is the largest output value. C sub 2 is the location of a relative minimum because in the open interval from a sub 2 to b sub 2, f of c is the smallest output value. Now I'm going to introduce the first derivative test. The first derivative test states the following. Let c be a critical number for a function f. Suppose that f is continuous on AB and differentiable on AB, except possibly at c, and that c is the only critical number for f in AB. F of c is a relative maximum of f if the derivative is positive in the interval AC and negative in the interval CB. F of c is a relative minimum of f if the derivative is negative in the interval AC and positive in the interval CB. Now I'm going to show you an example on how to find the relative extrema of a function by applying the first derivative test. In example 1, we want to find all relative extrema for the function f of x. And before we can do that, we need to determine the domain. The domain of f of x is all real numbers. And that is because f of x is a quadratic function. Now that we have the domain, we can go ahead and figure out the critical numbers. To do this, we need to determine where the derivative is equal to 0 and where the derivative is undefined. The derivative is negative 10x plus 20. Setting the derivative equal to 0 and solving for x will yield x is equal to 2. Since 2 is in the domain of f of x, we can conclude that 2 is a critical number. Now to determine where the derivative is undefined. The derivative is a linear function, so it is defined for all values of x. This implies that the only critical number is x is equal to 2. Now I'm going to create a number line. On this number line, I'm going to include x is equal to 2 because that is where the derivative is equal to 0. Now there are going to be two intervals to test. The first interval is going to be less than 2, and the second interval is going to be greater than 2. I'm going to start by testing the interval that's less than 2. I'm going to choose x is equal to 1. So the derivative at x is equal to 1 is 10, which is clearly greater than 0. So the derivative is positive when x is less than 2. Now I'm going to test the interval that's greater than 2. I'm going to let x equal 3. So the derivative at 3 is equal to negative 10, which is less than 0. This means that the derivative is negative when x is greater than 2. So now that we have this chart, we can go ahead and apply the first derivative test. Since x is equal to 2 is a critical number, and the derivative changes from positive to negative at x is equal to 2, there is a relative maximum at x is equal to 2. The value is 17. Now before I box this answer, I'm going to go ahead and graph f of x in Desmus to verify the results. So I've gone ahead and entered the function in Desmus, and you'll notice that there is indeed a relative maximum at x is equal to 2, and the value of that relative maximum is 17. And we are done.